In this unit, we'll be looking at the independent samples t-test. There are actually two types of t-tests: the independent samples t-test and the paired t-test. The independent samples t-test we are treating in this unit is a type of t-test we run when we have two groups that are independent of each other. There is a case where what happens in group A does not affect what happens in group B. They are quite independent. While we run the paired t-test when we have paired groups. But in this unit, we are looking at the independent samples t-test, which is a test we run when we have only two groups. But when our groups go beyond two, we run ANOVA. So it is expected that at the end of this unit, you should be able to decide which test to conduct for independent group and also be able to interpret the results. Okay, so let's go further to see what we can do. We have an exercise that says an experiment is designed in which 40 steel plates are randomly assigned. 20 plates are untreated and 20 plates are treated. So the activity we are expected to carry out says, assuming that the population variances from both conditions are equal, determine whether there are differences in the mean surface hardness of the treated and untreated steel plates. Before we go further to our data, let us look at the hypothesis for this test. Our null hypothesis says that there is no significant difference in the mean surface hardness of the treated and untreated steel plates, while our alternative says there is a significant difference in the mean surface hardness of the treated and untreated steel plates. So our decision rule here says we will reject the null hypothesis if the p-value is less than alpha, otherwise we will not. Mind you, our alpha in this test is 0.05, that's 5%. Before we go further to our data, I want to let you understand that independent samples t-test has two assumptions that must not be violated. One is that the groups must be independent of each other. Secondly, the variances must be equal. That's depending on what you are doing, or you assume that the variances are not equal. We'll discuss this further after we run the analysis. So let us go to Excel where we have the data to arrange it for the analysis. If you check in your exercise files folder, you will see the file called difference between two groups. So if you open it, you have this exercise. Now we have this data. We can't just copy this data to SPSS the way data look, because you have to arrange it for an independent samples t-test in SPSS. You must stack your data and have the categories on one side and the values on one side. So we have to do that now. To stack it, you highlight this area, click copy, come to somewhere here and paste. Okay, so copy the category, that is, click on the untreated, copy it, highlight this whole area and paste it. Then copy the values of treated, click here and click paste. I have it down there. So come to treated, copy it, highlight this whole area beside it, go back and click paste. So we have the category on one side. So we can call this surface hardness. Then the middle space we have, type your code there, and here we can call this our values. So we'll come to the code. We want to code untreated to be 1 and code treated to be 2. So type 1 on your keyboard, click here, go back to it, hold down this little knob here, drag it down to have the 1 spread down. So when you have done that, scroll up, click here. For treated, we want to code it to be 2. So type 2 on your keyboard, press enter, go back to this little knob here, drag it down. Okay, so we have our code and we have our values and everything set here. So now what we do is we copy the code and the values, not with the heading, mind you. Copy, highlight the whole thing, copy, and we move to SPSS. On the data view, right click here and click paste. So we have our data and the codes, but we're not done yet. We have to go to the variable view and define all this. So the name of the first one is surface hardness. Let's call it SH. Press enter to go down to the next one and call it values. Press enter for it to take it. So you can drag here, open a bit. For this, let's expressly tell SPSS what it is. It is surface hardness. Press enter. Let us call that one also values. It's still values. You can call it anything you want. So we have to code our surface hardness. Remember that our untreated is 1 and our treated is 2. So click here and click on this little knob, and here we enter 1. Press the tab on your keyboard to jump to label and type untreated. Press enter. Don't touch your mouse for now. It has jumped back to values. So type 2. That will be for treated. Press your tab, it jumps to the label. You type treated. Press enter for it to take it. Now use your mouse to click OK. Okay, we have done that. So go to measures. We know that our surface hardness, which has been coded, is nominal, and our values is scaled because it is quantitative. So we are good. Click on your data view. You'll see that everything is defined. So to now run the analysis, we go to analyze, move down to compare means, click on independent samples t-test. We have this dialog box out. So drag the values into the test variable area, then drag the surface hardness into the grouping variable area. When you drop it, you'll notice that it has 2 question marks. So these 2 question marks is actually requesting that we define the groups. So click on define groups. Click here and enter 1 for group 1. Click here and enter 2 for group 2. That's the codes we entered while we were defining or coding the surface hardness. So click continue and then click OK here for us to run our analysis. So our result is out. The first table says group statistics. This is where it shows us the descriptive statistics of treated and untreated. You see, for treated we have this line. We'll have our mean and the standard deviation and standard error of mean. The same for the treated. So the focus table here is the independent samples test. You see that down here we have equal variances assumed, and here we have equal variances not assumed. Remember that in our test we are assuming equal variances. What this means actually is that the 2 groups are not biasly fixed to compare their differences. That is, the variances in group A untreated and group B treated are quite equal. So in this case we have these 20 samples for treated and untreated randomly assigned. So we are assuming equal variances. So since we are assuming equal variances, what you do is double click anywhere in this table. It opens up this dialog box. I know that you also have another little dialog box, but mine is not showing because I actually closed it earlier. So I'm going to click on it to come up. So in case your own is lost also, you closed it anytime. When you double click on this, you find that it will not be showing. So what you do is you click on pivot and click on pivot trees. But I know that yours will just be automatically out when you double click the table. So when this little dialog box comes up, what you do is you drag this and click on the assumptions. These assumptions, click on it, drag it to this space up here and release it. It will drop there. You see something happened to this place. So since we have done this, you can now close this. So you see that it has equal variances assumed up here, and that's the result it has given us. We have nothing to do with the other result that says equal variances not assumed, unless you are working on equal variances not assumed. In that case, I will click this again. You go back and click equal variances not assumed. So close this. You see it gives you the result for equal variances not assumed, but we are actually working on equal variances assumed, right? So double click it again and select it. That's what we are working on. You can click anywhere for this to go off. Okay, so now that we have our result for equal variances assumed, which is what we are working on, you see that it has a special test it ran here called the Levene's test for equality of variances. This is the second assumption I talked about earlier, that you must not violate when you are running a test for equal variances assumed. So you see that our p-value is 0.313. This is the F calculated value. The Leven's test is good. We didn't violate it. So let's move over to our main test. This area shows us the t-test we have conducted. Okay, so here you see that our t calculated is this 4.104. Our degree of freedom is 38, and our p-value is 0.000, which shows that our test is significant. So now this is the difference. You see the difference between the means, that is between this and this here. This is the difference which we have tested, and the p-value which is less than the alpha, that's 0.05 in this case, shows that the test is significant. So we have to reject our null hypothesis that says there is no significant difference in the mean surface hardness of the two plates, and accept our alternative hypothesis that says that there is a significant difference in the mean surface hardness of the two plates. So this is quite good. Then if we must consider the particular group to use, in this case, you find out that when it is not treated, the average surface hardness was quite high, 165.0948, while after being treated, the average surface or mean surface hardness reduces, which is good, and the reduction after treatment is quite significant. That means the treatment, can also say that the treatment method was quite efficient. So this is where we draw the curtain in this unit. Thank you for being here with us so far. We'll meet in the next video, that is the paired t-test.